Hi, I'm CJ and this is my RC channel. Okay, I think I have figured out how I'm gonna handle this wiring. Remember, this is gonna be moving constantly, and so strain relief has to be a big factor because fatigue over time of these wires moving around and around, flexing at the connectors is a problem. So one of the things I'm going to do, I may use some extra heat shrink at this end, or a little plastic tab that attaches here, but I'm going to try to set up something that keeps this from bending at this point as much as possible. I made a pair of little wire whips made out of music wire. They're nice and flexible. You can bend them to the position you want, but they do tend to spring back to their, wherever you've got them. They are the same length, and I've bent a small hole at the bottom. I'm going to be using some washers, a pair of washers. Now, one of the nice things about getting all that extra hardware is that I can do this. I can take a couple of these washers, and I may actually need to use the slightly longer bolts. Might need to go get one or two, but basically just clamp this in between a small washer and a larger fender style washer, and that is going to attach along here. And I've got one just temporarily rigged with a twisty tie, and I'm going to hold this in position just to show you how this will function. So I may draw in a little more of the wire here. In fact, I'll just go ahead and do that for the example. So basically we've got as much of that slack as is reasonable pulled in, and this can come all the way in, and the wire just loops on up. This will be anchored down here, and then it extends, and as you can see, it's almost having no effect whatsoever here at the plug. And this could go back and forth, few 100,000 times and shouldn't have any impact. And so I would have another one on this side for this wire, and then for this cable, you can't just mount this up somewhere along here because this cradle is going to be moving back and forth. So what I may do is mount another one down here just to hold this wire in an outward position like this. That way it can go all the way back, come in, all the way back out. And again, I'll need to do some strain relief. Still working on this one, but I think these two for the forward edge here are going to work out great. One of the nice things is I don't even need to disassemble this completely to get the extra slide nuts into here. I can just take out this screw, slide the first one forward, and take out the second one, slide the second slide nut forward, and then put in the third one and anchor everything back up without having to take things completely apart. Likewise on this side, and depending on where I put the third whip, that may just be right here. And again, same process. In fact, if I'm anchoring this one to the top surface here, I can just slide it in from the side without having to unbolt anything. So this should work out nice. I just wanted to show you what direction I was going with this as I'm kind of working it out in my head how I want to do this. One thing I may do for these connectors to enhance strain relief is use some silicone and just kind of, you know, gob up a little silicone around there, you know, lay the wires out on a table and, you know, make the silicone go all the way around these wires and the top of the plug, so that there's kind of an anchor there, and it keeps everything together, keeps those wires from moving at their weakest spot. Let's see, is there anything else at the moment? No, I don't think so. I'm going to get started making measurements for the box and rummaging around for the hardware I'm going to need for that. I may be able to run the fans that I want, or fan. Basically, I'm going to be using a computer fan, and that might be able to be powered off of this port right here, or one of these two ports. I'm going to go online and see if I can find any documentation about this and what the outputs are. I mean, it's driving a bunch of motors, so this should be pretty good. And this output here is powering a laser, so I think it can spare a little bit of power to run a fan. But if that's an issue, I've got some other power blocks. I've even got the power supply for a PC, like a 350 watt power supply. I could strip all the extra wires off of that and bolt that to the back of the box I'm going to build to contain that to run the fan. And at that point, I could use multiple fans. So we'll see how it comes together. One thing I'm also considering is putting like a vacuum hose, kind of. Something a few people have mentioned is that not just the smoke, but there's soot and burnt material as a result of the process, especially when you're doing engraving versus cutting. And I mentioned this in the beginning of the video. A lot of especially professional grade machines like this will have a vacuum attachment that is drawing up. So I might be able to cannibalize a small vacuum cleaner and basically attach a small hose, maybe something in like an 1 to 3/4 inch diameter. And if you understand you know, the physics of pushing water and things like that, you know, going from a larger tube vacuum to a thinner tube vacuum is going to provide a higher level of suction, and that's, you know, what would be ideal. So having a tube that attaches to the side here, you know, might drill another hole or two in the acrylic here and use that as a mounting point, and have a hose that follows this around and is drawing up as much of the material as possible. Anyway, that's far down the line. You know, I'm going to basically kind of tinker with this mostly as is, minor modifications, and see where it goes. I've heard good things about this little laser as far as what I want to do with it, being able to cut the material. Several people have said, you know, ignore the instructions. The idea, and not in a complete way, but the idea that this can't cut through the thicknesses of balsa that you might want, or thin hobby grade plywood, is not true. It's a matter of doing the right settings for how quickly the laser moves, the power settings, things of that nature. And they actually provided settings. We'd definitely like to give them credit. Don't have that information handy at the moment, but when I get to the point where I'm testing and doing cuts and such, I will point you to their videos, provide you with links so you can listen to what they have to say, and I will provide the data and, of course, my own data that I will come up with as I test and test their numbers and their configuration. There's a lot of settings involved in using these, and getting the right results depends largely on how you adjust this and program it. So all of that will be covered. Okay, I needed to take the camera off so I could get in close on some stuff. So I have attached 2 whips right here. And this is just thin music wire. Forgive me, I'm not sure the exact size. And basically what I did to prevent these from having sharp edges that would potentially cut the wire, also to have a better mounting surface, I just took a small length of heat shrink tube and shrunk it around each end of the wire, left maybe 1/8 of an inch, millimeter or 2 sticking off the end, and let that crimp while it was still warm. And likewise up here, just double loop through a thin rubber band, and that allows for a little extra stretch on the whip. So just to kind of show you how that works. And the laser can move full range of motion anywhere on the operating area, and everything works just fine. Likewise, these do just fine too, all the way out and all the way back. And there's almost no motion at this point, so once I do a little strain relief there, that'll be set. This little extra, well, it's not extra, but the wire that's down here, I'm just going to tuck into this slot. I'm going to put a couple of zip ties around here and just leave enough loose here so that's not being strained against, and I'll do some strain relief there just to make everything as solid as possible. I didn't connect this one at because I wanted to show you how it looked unconnected and show you the heat shrink. So I'm just going to take some simple electrical tape, a couple of wraps at this end, and then do the zip ties, and that'll all be locked in. So everything looks good. It's coming along great. Okay, sorry about the noise in the background. I've got my 3D printer cranking away. I'm in the process of building the enclosure, and I just wanted to show you what I'm doing for strain relief. As you can see, these wires are now protected. They have the first coating of several of liquid tape. This is an excellent product, and you can see there's a little gap there. If I get in real close, you can probably see that. There, you can see the light passing through there. The stuff shrinks a teeny bit on as it cures. After a couple of coats, there'll be a nice solid coating, and these will not only be joined to the connector, but they'll also be joined to the heat shrink tape that was already there. It just doesn't extend that far. Because these plugs go almost flush, I can't get much around the edge, but a little bit will flow into the holes, not enough to cause a connectivity problem, but it'll solidify and make these have a lot less flex, and so that will provide a tremendous amount of strain relief. I've moved the board. I decided to mount it at a 90-degree angle. That way the cords come up and out, and that especially works well for the cord that goes to the laser and to the motor that moves the laser left and right. So it's going to be a little hard to reach a finger down in there to press the button, because I went a little tight on my tolerances for the depth of this. I didn't take into account this 3/4 inch that I was going to be placing in here. It'll all make sense once everything is assembled. I'll show you the process. I'm not going to bother to show you the process of cutting assorted pieces of plywood. This is all 3/4 inch ply and 3/16 inch, 1/4 inch ply. So this is the extent of the wood that is going to be used. There may be a few pieces along the top edge here. Basically, there's going to be a hinge at the rear. There's going to be a plexiglass top. The plexiglass top is probably going to be reinforced with some 1 by 1/4 inch thick strips of wood that'll get bolted along the edge here. And then there's going to be a plexiglass face that comes down. I've got a couple of latches that are going to go right about here on either side. And then there'll be a handle in the middle, and then there'll be a hinge that goes left to right across the top, joining the front plexiglass and top plexiglass sections. And then I'll be cutting holes in the rear here. Well, a hole for venting. I found some nice fittings back in the section where dryer hose is. 6-inch dryer hose seemed like the best way to vent to the outside, and there are some nice plastic fittings that will provide a mounting surface with 4 screw holes. So that'll mount in from the rear and provide the attachment point for the hose. I'll be using a couple of these fans. These are Noctua fans. Some of you may have heard of this brand. They make very quiet, almost silent fans. So there'll be one fan at the rear that pushes air into the hose, and then at the end of the hose I'm going to be using a piece of wood that will fit into a window with some foam around the edge, so it'll seal it. And there'll be another Noctua fan pulling air through the hose and out and expelling it. So that's the rough strokes right there on this enclosure. And it's probably going to be located very close to a window, so there'll probably only be about a foot of hose, maybe 1.5 feet at most. So it shouldn't be any trouble for those 2 fans to create a good bit of suction through this box. I'm going to be using just standard sticky foam insulating strips to seal the edges up top and the front face. And then I'll drill some holes in the front face to draw air in, and then it'll be expelled out the back, taking any fumes with it. I hope you enjoyed this video. Please click like and please subscribe to my channel.